Hello, 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 everybody, and welcome back. We're on the very last of the short answer, just give the final answer style questions, part A, from the 2016 Canadian Senior Contest. So we've got question 6 here, and, we do have 3 more questions to go in the contest, and these are the written ones. But I often find that A6 is quite hard. Sometimes B2 is harder, but I find more often than not A6 is harder than B2. The only thing that's consistently harder is B3, and of course we'll get to that eventually. But we're here for A6. So what have we got? A 9-digit positive integer n is called a Moffat number if its digits its digits are 0, 1, all the way up to 8 with no repetition. So I have to use these 9 digits here and just order them in some way. So that's a condition. The sum of each group of 5 digits in a row is divisible by 5. And the sum of each group of 7 digits in a row is divisible by 4. Okay. So those seem to be our only conditions. For example, 578460713 is not a Moffat number, because while the sum of each group of 7 digits in a row is divisible by 4, 4, 6, 12, 16, and then 8, so that's 24. Yeah, that's divisible by 4. I'm sure the other ones will work out as well. Not all of the sums of groups of 5 digits in a row are divisible by 5. The first 5 there are... well, 3, 1, 2, 0, 6. That's 12. That's not... Okay, alright. So, okay. I'm starting to understand what they're talking about. And we're being asked to determine the sum of all Moffat numbers. Okay. So, well, what could we do, just based off the nature of the question, what we're thinking about? Because the question involves a lot of different numbers. Like, essentially, a Moffat number is just an arrangement of the numbers 0 through 8. That's essentially what's going on there. We do have to make sure that 0 isn't in the front, but other than that, it's just some permutation, some rearranging. So if there's perhaps some order to the permutations, like... obviously not all rearrangements will work, but maybe if something like... the second digit is only ever a 2 or a 4, and it's split evenly amongst those options, and we know that we have, 12 Moffat numbers, then in the 100,000th place, we'll get either 200,000 part of our sum or 400,000 part of our sum, and each of those will appear 6 times. And so there might be a fast way to add up all these Moffat numbers. Alternatively... we might have to just work out all the Moffat numbers. There might only be, 3 or 4 or something like that. And it's just up to us to... And the math is, how do we set up Moffat numbers, and how can we rule out, well, this isn't a Moffat number. Your Moffat numbers have to start 1, 2, 3, or whatever. So we're going to... I guess the easiest thing to do is start to investigate what Moffat numbers look like. If we can get a small list, we can add them all up. If not, we're going to have to start noticing, as we analyze these things, patterns of, well, this digit, the tens digit can only ever be these 3 numbers, and it'll be spaced equally amongst all 48 different Moffat numbers. That sort of a thing. Anyway, let's get into it. Okay, so 0 through 8, 5 digits in a row divisible by 5, 7 digits in a row divisible by 4. All right. Now, what could we do? Well, I'm going to, I suppose, name the digits. And there's lots of ways to do this. I'm probably just going to name them. I'll do D0, D1, D2, D4, D5... I may abandon this later. But there we go. There's 9 digits, and I do have the 0 through 8 to remind myself that those are the numbers. So, D0 is whatever the lead number is. So right off the bat, I should probably make a little note to myself. D0 can't itself be 0. Okay. It'd be interesting to know, maybe, and this would actually make an interesting question because I don't think this is the answer, but to count up the number of ways 0 can't go here, 1 can't go here, 2 can't go here. I think those are called derangements. And, those would be pretty interesting. But, okay, so what have we got? Well, we know every group of 5 has to be divisible by 5. So, for example, D0 plus D1 plus D2 plus D3 plus D4 is a multiple of 5. But so is the next one. We just shift over 1. That's divisible by 5. And, we can keep doing this. And I suppose I got time. I can write them all out. But the sums aren't particularly interesting. Things I would draw your attention to are the fact that successive sums that I'm writing down differ from the previous sums only slightly. We're just shifting over by one number. So, for example, these two up here, they're divisible by 5. But the different, they both have D1 up to D4 being added. So if I were to do something like call this 5 times K and call this sum 5 times M, I know they're multiples of 5, that's why I can do this, then the difference between the two is really, because the two blue parts will cancel out, it's really just D5 minus D0. So 5 divides D5 minus D0. Similarly, 5 divides, so the difference in these two, 5 divides D6 minus D1. 5 divides D7 minus D2. Divides D8 minus D3. And that's it. And that's pretty interesting. Especially when we're dealing with the numbers 0 all the way up through 8. Because that sort of pairs things off. If I know that D8, for example, is 8, that forces D3 to be 3. And so we get sort of pairs. And, interestingly enough, there's 4 here in the middle. 4 and no other digit are paired up. So, how do we want to write this? I know we don't have to write it up nice, neat, and formal, because it is just a part A question, but 0 and 5 must be 5 spaces away. And so maybe there's a fast way to count it up knowing that this is true. And all of these 4 can't be, I was saying must, 4 can't be paired up. And the only one that wasn't paired up with another digit was D4. D4 did not appear in any of my differences. So that tells me D4 is 4. 4 has to be the middle number. And so, now I know that, if there are 10 Moffat numbers, then the 10,000th digit of all of them is 4. And so that would mean I'm adding 10 copies of 40,000 when I do my final sum. Remember, when we separate things by digits, to add everything up is just to add the individual digits and their corresponding place values. Okay? If you've got a 2 consistently in your tens digit, you just need to add up 20, the number of times you have Moffat numbers, that sort of a thing. So I always have a 4, it's always blah, 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 40,000 and blah, blah, blah. So, there's no reason I have to add up all the numbers together. Why don't I just, add the 10,000th digits all together? Well, there's 10 Moffat numbers, and each 10,000th digit is 4, so that's 10 times 40,000. That sort of a thing. So if we can break it down that way, that's quite nice and useful. So there's always the 4 in the middle. That's pretty nifty. Is there anything else I can do? Well, You know, I would hesitate to do anything with the 5s right now. But I like that these things are paired up. Because, you know, the 0 and the 5 means, you know, you'll get certain sums and certain possibilities. But we can also note D0 plus D1 plus, I'm not going to write them all out, you guys understand the patterns at this point. But we have to have sums of 7 in a row are divisible by 4. Excuse me. And so once again, we can see things, well, the difference between these two is one of them has a D7, one of them has a D0, but the D1 through D6s are common to both sums. So D7 minus D0, 4 divides that. And 4 divides D8 minus D1. And there's not a whole lot else here. So this isn't the most useful tool. Yeah, it wasn't as exciting as the divisibility by 5. Well, I guess I'm trying to think if there's anything we can... this doesn't seem like a whole lot of interesting or new information here. It's just, well, it's the logical thing you would get with the divisibility by 4. And it doesn't even narrow things down, really. So what is there to do? There's not a whole lot that I can think to do. One thing I would note, I think it looks like there's symmetry in these, they're 9-digit numbers, they always have 4 in the middle, and I suspect that if D0 through D8 is a Moffat number, then arranging them with D8 as the leading digit, and then D0, that might be a Moffat number as well. Excepting our good friend 0 over here, who causes problems. Yeah. Well, the problem is I don't seem to be able to do anything here. I could, I guess, list groups, 0, 4, and 8. Except 4 will never be used for any of these. 4 will never be D0 or D7 or D1 or D8 because we already know 4 is right in the middle. So 0 and 8, what other things are 4 away? 1 and 9, well, no, we've got 9. 1 and 5, 2 and 6, 3 and 7, and then, well, we've got 4 and 8. So the fact that 4 is in the middle kind of very nicely arranges these guys into little interesting pairs almost. And with this information here and this information up here, I suppose we might just say something like, well, what if the first digit were 7? And then, well, we'd know that D1 is 3, and then that would force certain other numbers. So let's see what we can do. Let's see if we can make a Moffat number. I'm going to start with 7. So D0, D1, D2, D3, D4, D5, D6, D7, D8. So this is just an experimentation. I'm not doing this in a rigorous or orderly manner. I'm just saying what knowledge am I missing, or can I just start making Moffat numbers? So a 7 here, then D7 is also has to be 3. So we'll put therefore 3, and D5 has to be 2. And if D7 is 3, then D2, which is 5 away, has to be 8. We know that 4 is always in the middle. And so there we go. And then I guess we get to make another choice. We can make D1. In which case, what could we have? Well, we could have certain... So I'm just trying to quantify how many choices we have. Once we made this 7, that sort of nailed down 3 other numbers. And I think once we choose this D1, that's going to nail down a set number of numbers. And so, choose D0. And there's 7 choices there. And then I guess choose D1. And so once I choose 7, that gets me 3 more, so then there's 4 choices for D1. So, yeah, is that really it? I feel like that's it. Now, I say 7 choices for D0 because you can't have 0. Although maybe we could have 5 choices for D1, in which case then wouldn't there be 35 Moffat numbers? Interesting things to think about. I haven't actually made a Moffat number yet. Let's pick D1 is 1. Let's say. So if that's 1, then D8 has to be 5. If D8 is 5, then D0 is 3. And if D1 is 1, then D6 has got to be 6. So that turned out to be a Moffat number. Now, the other thing I'm thinking about is we have these pairs, 0, 5, 1, 1, 6, 2, 7, 3, 8. So those are for the divisibility by 5. And then we also have 0, 8, 1, 5, 2, 6, 3, 7. And I'm worried that there might be some ways that we can't fit these guys together. So let's see if we can find a way to make this not work out. So what I would need is something like 1 has to be in 2 places at the same time. That's what I'm looking to try and do. But, I mean, this one here is clearly a Moffat number, right? Sum of 20, and then sum of 15, and then a sum of 20 again, a sum of 15, and then finally the last ones are a sum of 20 again. And the first 7 is 16, 4, and then another 8, so yeah, that's fine. And yeah, so this all seems, this number here, 718042635, is a Moffat number. I'm worried that these conditions here can overlap in some sort of very, very cranky, very bad way. So, if that's the case, what is it? What's the problem? So let's see if we can break this. How about something like, I don't know, 2 first, and then that would force this to be 7. 4 again, obviously in the middle, and that would make this guy 6. I'm running out of space. And if this one's 6, then 7, then 5 away has got to be 1. Okay. But that all worked out. And then what could I do? Well, I could have 0 here, and then that would put 8 here. And if 8's there, then that means 3 has got to go here. And if 0's here, that would mean 5 has to go here. And that also looks like a Moffat number. Okay. So, can we think of a reason why these things... can we think of a reason why this will always work out? That these overlaps won't cause me any problems? Well, let's think about that. And also, let's double check. This is a Moffat number. 2 and 5. Yeah, that's 10. Yeah, I'm growing confident that this is a method to create Moffat numbers. Certainly. And we are using all the numbers 0 through 8 correctly, so I feel like this is becoming too easy, and now it's just we'll just need to count up the 35 different Moffat numbers, because that's what it looks like we're going to have, is 35 different Moffat numbers. So, what if... So that's 4, that's... 4, 4, 4... Okay, wait a minute. Something has gone wrong. Okay, so that's 2, that's 4, that's 4, that's 12. We don't actually have divisibility by 4. Oh, okay. So all these pairs of numbers that I've got together... Okay, I knew it couldn't be this easy. All these pairs of numbers here together just ensure that if these 7 here are divisible by 4, then having the 6 here will make the next one divisible by 4, and the next one divisible by... We do still have to start with divisibility by 4, and we do still have to start off with something being divisible by 7. Or, sorry, 5. I think I've just gotten lucky each time. Well, obviously not this time. Okay. So there is that final twist. Good, because I was worried this A6 had seemed a little too straightforward. You know, just pairs of numbers and combine them? No, it's far too simple. Alright, so what is there to do? Well, the fact that the 4 here is the very end of our first 5 might be something worth exploring. You know, let's see if we can guarantee that those first 5 are indeed a multiple of 5, and then go from there. So we've identified what we're missing. Now the question is, how can we correct it? Okay. So, D0, D1, D2, D3, and 4, I need that to add up and be divisible by 5. Now with the 4 there, I need D0, D1, D2, and D3 to be congruent to 1 when I divide by 5. That's the new challenge. So... I feel like there's too much variability here. I don't want to have to sort of nail down 4 different numbers. Indeed, I shouldn't. I liked what I was doing. I don't have enough space. I liked the picking D0, and I'm wondering could I just, because I know I got a 4 here, could I just go through and say, well, if this is 1, then that forces D5 to be 6, and it forces D7 to be 5. And those come back and force other things. So the D5 comes, or sorry, the D7 forces D2 to be 0. So is there some pattern in, if I put a 1 here, if I put 1 which is congruent to if I put 1 here which is congruent to 1 mod 5, that forces something that's 0 mod 5 or something like that? Because I know once I do my choices, as long as I pick a single number here and follow it through, I will get a Moffat number, provided that these first few add up to something that's divisible by 5, and these first 7 here add up to something that's divisible by 7. So if D1 is, if D0 is 1, D2 is 0. What if D0 is 2? Well, we did just go through this, but let's do it again a little more orderly, and maybe we can notice a pattern. If D0 is blah, that forces D2 to be blah, and then we can do a similar sort of thing with D1 and D3, because it's the exact same reasoning. Like if I put a 1 here, I'm going to get a 5 down here, and I'm going to get a 6 right here, and that'll put a 0 here. So my initial, I'll call it DI being 1, that forces DI plus 2 to be 0, and that, I think, will impact this in some particular way. What if we had a 2 here? If we had a 2 here, then we'd have add 4, we'd get a 6 here, subtract 5, we'd get a 1 here. Oh! So a 3 would put a 2 here. A 4 would put a 3 here. The only time this doesn't work is if we start putting a 5 here, we can't get a 4 here. So 5 would bounce out to, so it should go to 9, but it doesn't, so it goes to 1. And then we jump up by 5 to 6. Okay, so it's x and then x minus 1 if x is less than 5. X plus 1. Oh, obviously we can't have a 4 here. So less than 4, x plus 1 if x is greater than 4. And that's the same for D0 and D3, except for 0. What happens if I put 0 where D1 is? Well, then I should bounce up to 8. 8 has to go at D8. And then, so that goes up by 8, which is kind of odd. And then we come back by 5, so it'd be 3. So 0 and 3 are paired in this way. Alright, so I'm beginning to understand how this works. So my Moffat numbers would be, so if D0 is less than 4, then we'll have, then D2 is D0 minus 1. And if D1 is less than 4 but greater than 0, sorry, I'm still getting over a cold from the last couple days, then D3 is D1 minus 1. And so now I've got D0 plus D1 plus D2 plus D3 plus 4. The sum of my first 5 is now 2D0 minus 1 plus 2D1 minus 1 plus 4. So that would be 2d0 plus d1 plus 2. And that's got to be divisible by 4. Or sorry, divisible by 5. So this number here, because it's obviously a multiple of 2, is either 10 or maybe it's 20, but I very much doubt that it's 20. Yeah, because these two numbers here would have to add up to 9, but they're both less than 4. So it's clearly 10. So d0 plus d1 is equal to 4. So I could have 1, 3. I could have... Can't have 2, 2. I can't have 4, 0. I could have 3, 1. Right? So the question is, do those lead to Moffett numbers? Yeah, that's the question now. Do those lead to Moffett numbers? Because specifying those two is exactly what we need. So 1, 3, and then that would force 0 and 2. And then we'd have 4, and then we could just read them off because they're separated by 5. So 6, 8, 5, 7. Is this a Moffett number? Divisible by 5, and therefore all the other ones are divisible by 5. So the question is, now, is this also divisible by 7? And so 1, 3, 2, 4, that's 10. Plus 6 is 16. Plus 8 is 24. This is not a Moffett number. What if I did 3, 1... 3 would go to 2, 1 would go to 0, 4, 8, 6, 7, 5. So we still have the same 10 that we start with. 8 and 6. No, this isn't working either. Okay. So these two aren't Moffett numbers. What if I had d less than, or d0 is less than 4, d1 is equal to 0? Well, then I'd have 0, I'd have 3, I'd have d0, d0 minus 1, and 4. So I'd need 2d0 minus 1 plus 7. 2d0 plus 6 is divisible by 5. I wonder if focusing on divisibility by 7 would be faster, but... So d0 is less than 4, so this is at most 6, so this is at most 12, so this has got to be 10 again. And that would force d0 to be equal to 2. So I'd have 2, 0, 1, 3, 4, and then we'd get 7, 5, 6, 8. And so what would we have? We'd have the same 10 that we keep having. 17, 22. This is also not a Moffett number. I'm getting a little discouraged, but... Alright, there are other possibilities. What if d0 is greater than 4? And then we do some of this stuff. Or, actually, no, we still have about d0 less than 4, d1 greater than 4. So that would force, so we'd have d0, d1, d0 minus 1, and then I wonder what happens. Is 8 a problem for this? 8 goes to 0 at the end, which comes back to 5. So 8's a problem as well, I feel. This is starting to become more trouble than I bargained for. But let's see. So these guys cancel out. So 5 divides 2 times d0 plus d1 plus 4. This could be 10. Could also be 20, I think. If it were 10, then D1 plus D0 would have to be 6. Or, sorry, 3. That's not happening. Because one of them's at least 5. 20, what else could we have? We could have 30, maybe. Because that'd be 26, and then D0 plus D1 has to be 13. Which can't happen, so that's out, that's out. So it's got to be 20. So D0 plus D1 is equal to 8. Interesting, because before they had to add up to 4. I'm noticing some numbers and some intrigue. Very, very interesting things. So that could be something like 1 and 7. That could be 2 and 6. That could be 3 and 5. You can't have multiple 4s. So, well, what Moffat numbers or what Moffat-looking numbers do we get here? 1, 5. By the way, just to address the way I started this off, I'm not noticing enough of a pattern to be able to say, well, these are all the 1 columns, these are all the 2s. So I think we're probably just going to end up listing things out, which I think makes this a bit of a poorer question, but what can you do? So that'll be 0, and that'll be 8 there, 4 here. Really, is it 0 and 8? Yeah, okay. And then we get 6, 2, 5, and 3. And the question is this a Moffat number? Well, I just need to check the first 7. So 1, 7, that's 8, 16, 20, 28. Oh, we have a Moffat number. We have a Moffat number. Yay. Okay, good. So the last few examples have not gone well for me. So 1 and 7. Also, the reasoning here, it's the same formulas, I would think. So I should think 7 and 1 would also... We'll get to that. We'll get to that. How about 2 and 6? 2 and 6, that forces 1 and 7 and 4 here. And that's going to be... Well, whatever these two are, I just... oh, no, I don't add 5. I add 5 to one, but subtract 5 from the other. Wait a minute, what? Hey, that's not allowed. We got 1 in multiple locations. Okay, so obviously that's not a Moffat number because it won't even work. How about 3 and 5? 3 and 5 goes to 2 and 6, and we've got 4 here. So the 3 jumps up to 8, the 5 goes down to 0, and the 2 goes up to 7, the 6 goes down to 1. Alright, so 3 and 5 is 8, 2 is 10, another 10, so that's 20, 28. Once again, we have a Moffat number. Okay, so we've got 2 Moffat numbers, and we're not entirely done all this. Oh, actually, these guys are the same number in reverse, which I think I mentioned earlier. I think reverse Moffat order or Moffat numbers can work. All right, so that's all the cases with D0 is less than 4. Now let's try D0 is... Oh, no, D0 less than 4 and D1 is 8. So we would have D0, we'd have 8, we'd have D0 minus 1. 8 goes out to 0 and then comes back as 5. And then 4. So we'd have 2D0 minus 1 plus 9. So this will be plus 16. And this also has to be divisible by 5. Well, D0 is less than 4, so it's going to have to be D0 is 2, and the sum is 20. So let's try it out. 2, 8, 1, 5, 4. The 2 bounces up to a 7. The 8 falls down to a 3. The 1 jumps up to a 6, and the 5 goes down to a 0. 2 and 8 is 10. 1 and 5 is 16. 20, 27, 30. No, not a Moffat number. Okay, but worth experimenting. Worth trying. Alright, so that's everything with D0 less than 4. Now let's try D0 greater than 4. So if D0 is greater than 4, we could still have D1 being equal to 0. We'd have D0, 0. We'd have D0 now is plus 1. And the 0 would go out to an 8. And then the 8 would come back to a 3. Okay. And then there's a 4 here. So we'd have 2D0 plus 8 is a multiple of 5. D0 is greater than 4, so we would have at least 16 here. I'm going to guess this is going to have to also be 20. Because at most that's 24. So yeah, it's 20, and therefore D0 is equal to 6. So 6, 0, 7, 3, 4. The 6 goes down to a 1. The 0 bumps up to a 5. The 7 goes down to a 2, and the 8 comes up to a 3. Or the 3 comes up to an 8. 6, 3 is 9. 7 is 16. 4 is 20. We have 26 here. Not a Moffat number. I suppose I could just look at the last two and subtract them from the total. So some of the numbers from 0 up to 8 is 36, so just subtracting the last two off is enough. But no Moffat number there. Okay. We could have D0 is between 4 and 8, and D1 is just plain old less than 4. Alright, so I can have D0, I'd have D1, D0 plus 1, D1 minus 1, and 4. We've been down this road before. We have 2 D0 plus D1 plus 4, and that's a multiple of 5. Alright, and this one has to be 20. We already saw this before. It's just, and then D0 plus D1 is equal to 8. But now it's the D0 that could be 7. D1 could be 1. D7 could be 6. Or sorry, D0 could be 6 or 5. And we'd have 2 and 3. And the other question is, how are these going to play out? So the 4 goes over here. The 7 bumps up to an 8. The 1 goes down to a 0. The 7 goes down to a 2. 6, 3, and 5. And the last two are 8. 36 minus 8 is 28. Moffat number. 6 and 2 will give me... I'll put the 4 here. So the 6 goes up to a 7. The 2 goes down to a 1. I think we've seen this cause a problem before. The 6 goes down to a 1, so no, we're already done here. 5 and 3, I suspect this will be a Moffat number then. 5 goes down to a 0. 4 here. Oh, not a 4, it's a 6. It's a 6. 6 here, 2 here, and yeah, it'll be 7 and 1. Or sorry, 1 and 7, because it's the reverse of the one that we just saw. So it'll be 8 here. And this is also a Moffat number. So I sort of need these two digits to add up to an 8, and I wonder if I'd made that observation sooner. I suppose they could add up to a 1, couldn't it? No, because it needs to be a multiple of 4. Oh, have I been doing this wrong? I feel like I've been checking these for being multiples of 7. Not multiples of 4. Nope, it's all worked out. Did it work out? I feel like... Let's just check these earlier ones that I didn't actually write numbers for. 1, 3, 0, 2, 4. So the last two digits are 12. So no, that is a multiple of 4. So these are actually Moffat numbers. But these, so 3, 1, 2, 4, so that's 4, that's 10, and then 8, so that's 18, and then 6 is 24. So yeah, these were Moffat numbers all along. Oh, so the last two numbers have to add up to a multiple of 4. That's what we're looking for. But since the reverse of a Moffat number is a Moffat number, don't just the first two have to add up to a multiple of 4? Interesting things to think about. Although I think we've got 6 Moffat numbers so far. And then what other cases are there to be had? So, yeah, because D0 plus D1 has to be divisible by 4. And I think this is actually going to narrow some things down. Right? Because the last 7 digits have to be divisible by 4, just like the first 7 and the middle 7. So, yeah, that narrows things down nicely, and it's been working out for us quite well. Anyway, what did we just do? So we had D0 is between 8 and 4. We had D1 is strictly less than 4. We could have D1 between 8 and 4 as well. And then we'd have D0, D1, D0 plus 1, D1 plus 1, and 4. So that would be 2 D0 plus D1s plus 6. 5 has to be divisible by that. This is between 22 and 38, so this is going to be 30. So 2 D0 plus D1 has to be equal to 24. So D0 plus D1 has got to be equal to 12. Yes? Okay. So really we could have 5 and 7. Because you can't have 2 6s. So yeah, 5 and 7. And these ones should work out, but while we're at it, we got to write them out if we're going to add them up anyway. So 5 and 7. And 7 and 5, I suppose. 5 and 7, we get the 4 here. He goes up to a 6 and an 8, or an 8 and a 6. It's going to be the reverse of the one we saw earlier. The 5 goes down to a 0. 0 here, 2, 2, 1, 3, 3, and 1. Both Moffat numbers. Fantastic. Okay. And then I suppose we could have D1 be 8. But then that would force D0 to be 0 or 4, so D1 can't be 8, so we don't even need to worry about that. The last thing we could worry about is D0 is 8, and therefore D1 would have to be 0, because these guys have to add up to a multiple of 4. And 8, 0, a 4 here, 8 goes down to 5, and 0 goes up to 3. But this would have to... Well, no. Would this have to be a palindrome? I feel like this would have to be a palindrome. Anyway, the 8 would go down to a 3 here, and suddenly I realized there's a problem. This would have to go up to a 5. The 8 would have to jump down to a 0 here, and this would... So, this is a Moffat number. It's just... Well, it's everything but a Moffat number, because you can't have the repeats. Okay, no repeats. So I feel like we have all the Moffat numbers, because we've exhausted all our possibilities. So what did we have? We had 1 and 3, 3 and 1. Most recently we had 5 and 7, 7 and 5. And then we had a couple in the middle. So 1 and 7, 7 and 1, and 3 and 5, 5 and 3. So even numbers here, seemingly in short supply. So the 4s... 3, 4, 5. So only 8 Moffat numbers, because we were quite rigorous. All right. Okay. So the ones go down to zeros. Let's just we'll fill this out very slowly, very methodically. The ones also pop up to 5. No. Sixes. Sixes when you're 5 away. Sixes, see, I got to be very, very careful with this. 6 is here. And 6 goes here. Alright, now the 3s. The 3s pop down to 2. So we have 4 2s. We also have 4 zeros. We got 4 1s. It's very interesting. Looks like all the even numbers are concentrated in the middle, because these zeros, the 3s will pop up to 8s here. Yeah. Oh, sorry, this isn't an 8. See, you gotta be very careful with this. I'm sort of losing track of what I'm doing. This isn't an 8 either. 8s are just with the 3s. Okay, stay focused. Come on, Root Beer. The 5s. The 5s go up to 6s. 6, 6. Alright, and then the 5s go down to 1s on the other side. No, they go down to 0s. Gosh. Come all this way. I do not want an arithmetic mistake at the very end of the video. Okay, now we've got the 7s. So these 7s go up to 8. And they go down to 2. Okay. Now these remaining zeros go up to 5. The remaining 2s go up to 7. Well, really, it's just whatever numbers weren't listed. That's not a 7 as well. Stop filling this out on autopilot. Okay. 7 here, 7 here. Okay. The 8s go down to 3s. There's an 8. There's an 8. There's an 8. There's an 8. And the 6s go down to 1s. There's a 1. There's a 1. There's a 1. There's a 1. Alright, quick cursory glance. Do I have... It looks like in pairs of columns almost. I'll have 4 7s, 4 5s, 4 3s, 4 1s. Looks like all of that's working out. So actually that might be a fast way to add this. Now I do have the list, and certainly calculators are allowed. They absolutely are. So we can just add this all up, and if you think that's faster than seeking patterns here, by all means go for it. Okay. I'm not going to do that because I think it's kind of boring to watch me use a calculator, so I'm just going to do the slightly longer process of trying to identify some patterns here. Okay? So, let's go back and take a look. So as I say, so it's 8 times 40,000. We definitely have that. And then we have 2 1s in the 1s column, 2 1s in the 10s column, 2 1s in the, that would be 10 millions columns, and 2 1s in the 100 millions columns. And same with 2 3s, 2 4s, 2 3s, 2 5s, and 2 7s. So I could correctly say something like this is 2 times, because we've got 2 1s, 3s, and 5s in each of the 100 millions, 10 millions, and also the 10s and 1s columns. Plus 8 times 4 in the 10,000s columns. And then finally 2 times, we've got the 0s, the 2s, the 4s, the 6s in those middle columns. So 1, 1, 0, 1, 1, and then 0, 0. Okay? Because I get 2 zeros in, the hundreds columns, 2 2s, 2 4s, and 2 6s. No, not 4s. Jeez, I don't know why my arithmetic is failing me when all the analysis up to this point has just been so sparkly and wonderful. Alright, now I can simplify some of this. 1 plus 3 plus 5 plus 7, that's 16. This is also 16. 2 times 16, 32. This is 32. This is 32. And so now I've got 32 times, and then just ones. 9 ones. Oh, that's kind of interesting. And so that's a much simpler calculation to make. 32 times 1, 1, 1, 1, 1, 1, 1, 1, 1. Much easier on my calculator. And assuming I didn't miswrite the number of 5s. Actually, 32 times this many 1s I probably could have done without a calculator, but I chose to use a calculator. 8 5s in the middle. Let's just see. 2, 4, 6, 8. Yeah, 8 5s in the middle. And that's going to be our final answer. Okay. So, just, don't follow my example. The analysis was fine. I probably should have caught on to the first two and last two have to be a multiple 4 a little faster. And if I hadn't noticed that, I wouldn't have gone back, and I would have thought I didn't have Moffat numbers when I did. So, I've been fumbling this entire thing. But I should have noticed that a little faster, I feel. What else? Certainly the patterns were fine. It started off too easy, as I noted, so I started looking for other things and making sure I did have Moffat numbers. And just, oh man, filling out that list, I just kept going on autopilot, filling things in when they shouldn't have been filled in with those particular numbers. And I feel like that would have been terrible, not only for noticing patterns, which is the way I did it at the end, but certainly if I grabbed my calculator and just added up the numbers that I thought were Moffat numbers, without double checking that they were Moffat numbers, or without being very careful when I made up my list. That would have killed me. Absolutely killed me. Now, if I remember the marking scheme correctly for this, I think you got a pity mark for having a Moffat number. I think if you had 3 Moffat numbers, you got some more marks. But I think that was about it. I think there might have been 1 or 2 marks for showing a little bit of reasoning. But this one, it was, as I recall, it was a whole year ago. But I feel like we didn't give out that many part marks for this one. It was either you got the final answer, not many people got this one. It's A6, it's hard. Or, maybe you got 1 Moffat number. But there were not a lot of 3s and 4s handed out for this one. But that's it. That's A6. That finishes A part of the contest. I will see you guys for the written questions, starting with B1 in the next video. Until then, take care.